Geotechnical Engineering, Part A, Soil Mechanics, Session 12, Chapter 3, Weight-Volume Relationships. In this example, we have a dry weight unit of a soil. We have a soil sample which has a dry unit weight of 1760 kg over cube meters and a saturated unit weight of 2050 kilogram per meter cubed. We want to calculate its wet unit weight or gamma T at saturation ratio of a 80%. So we want to calculate gamma when SR is 80%. Gamma total then is 80% saturated. Mhm. So we will solve this problem with a two approaches. So solution one, based off problem statement, we do have gamma D and gamma saturated of 1760 and 2050 kilogram per meter cubed. And based off weight volume relationship equations, we do know gamma D dry unit weight is GS specific gravity over 1 plus void ratio times unit weight of water, and gamma saturated uh, unit saturated unit weight is a GS plus E this time over 1 plus E times gamma W. If we divide these two equations, it just gives a relation of these two gamma D over gamma saturated is just GS over, so gamma W is cancelled out from both sides, and we have the relation of GS over GS plus E. 1 over E is cancelled out as also. So if we have this equation and we just replace our numeric values, so 1760 over 2050 is equal to GS over GS plus E, we can definitely get a relation based off GS and void ratios. So it just gives us if you just multiply it like a 7060 GS plus 7060 void ratio is equal to 2050 times GS, and if you just do the math and simplify the equation, it just gives us void ratio is equal to 0.165 times specific gravity. Mhm. So far, we get a relation between GS which connect GS to void ratio. And at the same time, gamma D is GS over 1 plus E times gamma W. If we replace the E equation, this is a E which is directly comes from here. So we have an equation which is the only unknown is specific gravity of the soil grains. And gamma W, we already know that's in it's 100 kilogram per cube meters or 1 gram per cube centimeters. So if we do know this equation, and if we just solve the equation based off the only unknown of a specific gravity, it just gives us a specific gravity equal to 2.4802 as soon as we have the specific gravity. So now if we just go for gamma T formula, which is GS plus GS times double omega percent over W water content over 1 plus E times gamma W, it just and at the same time we do know we want to use gamma total in a way that we have 80% saturated. So SR times E is equal to a W times GS from another equation in weight volume relationship, and the point that we keep solving different problem in this chapter is to a kind of a firm understanding of and stabilizing the uh, formula and their usage. So when SR is 80% based off problem statement, and then just 8.8 times E is equal to water content W times GS. Mhm. And it just gives us a omega of which we need to use it here. Mhm. Water content is equal to 0.132, and it directly goes to gamma T formula. And if we just use the moisture content based off 80%, we can easily solve the problem for a 80% saturated unit weight. So gamma T is equal to GS, which we already calculate, 1 plus moisture content for 80% saturation over 1 plus E, and E is nothing but just a 1.165 times GS. So that's 0.165 times GS, and GS is 2.4802. If you do the math, it just gives you zero point 0.4 something times gamma W, and it just simply gives you gamma total of, that's for 80 percentile saturation, of 1992.33 kg over meter cubed. The interesting part is yet we can solve this problem in a far easier approach. Mhm. Solution 2, it just, if you remember, we had a relation which connects the unit wet unit weight, which here stands for gamma total. So gamma T can be from a, for example, 2% saturation to 99% saturation of a soil sample, and its dry unit weight, which is gamma D, gamma dry, and saturated, which is gamma T. Wow, that's interesting if we have a one equation which connect these three components to each other. So that's interesting, and it just gives us the solution itself. So if we just replace, and we want to have gamma T, which is gamma wet, and that's for saturation ratio of 80%. So simply we can replace them in equation. So gamma T is equal to gamma D, which is 7060 problem statement. SR is problem statement. Difference between these two gamma, 2050 minus 7060, gives us 1992 kilogram per meter cubed, and we already solved that with approach 1 to be 1992.33, almost a negligible difference. And if we'll solve more problems, thank you.